Hi, everybody. So today is March 26th, 2020, and we're going to start our Earth Science. Now, I kind of said the other day, when I was talking about the last time I saw you in school, about what Earth Science was. I talked about it being the study of geology, which is the study of the solid Earth, rocks, and how continents are made. So geology is the study of rocks, or the study of the solid Earth. What makes a rock a rock? Another branch of Earth science is oceanography. And as the name implies, this is the study of the oceans. I can't spell tonight. The studies of the ocean, and tied closely with oceanography is the climate, which is global weather. And we will eventually be covering these three topics when we are talking about Earth science. So let's take a look at our planet, the Earth. We're going to start in the very center of the Earth. The very center of the Earth, as you may or may not know, is called the core. So here's our planet, and this is a cutout section. Imagine it was like a giant peach, and I cut a piece out. The very center part of the Earth, these two sections are called the core. It's made up of the inner core and the outer core. So we have the inner core and the outer core. The inner core is solid. It is made up mostly of iron and nickel. It's hotter than the outer core, but there's so much pressure on the inner core, it keeps it solid. Next up on our way out from the center of the Earth is the outer core. The outer core is molten. That's a fancy way of saying liquid rock. So it is molten iron and nickel, and it is our outer core spinning that generates the Earth's magnetic field. So this gives the Earth So I just have to comment, completely off topic of the planet Earth. Eleanor is upstairs right now, and she's watching Mamma Mia, and I can hear it in the background. I don't know if you guys can hear it, and if you can, I apologize. Anyway, back to the planet Earth. The next two layers are the mantle. The mantle is the thickest layer. And it is made up of two slightly different layers. It has a hot gooey magma. Gooey, can't spell tonight. We'll go with that. So it has a hot gooey layer of magma. And it sets up these convection currents. And it is these convection currents. It's these convection currents. These are the convection currents. If you guys remember from when we talked about thermodynamics and how things that are hotter rise while things that are cooler sink, these convection currents move the hot magma around, and they are what move our continents. On top of the mantle is the crust. This layer is 0 excuse me, to 100 kilometers thick. Excuse me. It is mostly rock and soil. Excuse me. Okay. That is the inside of the Earth. The crust contains the next two layers. The first we call the biosphere. Eighth graders, you might remember that bio means life and sphere means circle. So the biosphere is the layer that contains all life. The biosphere sits on top of the layer that we call the lithosphere. And this is the crust and mantle. Basically, the rocks that make up the planet. And sitting on top of the lithosphere is the hydrosphere. The word hydro means water, sphere means circle. So this hydrosphere contains all the water on the planet. Okay. Now, in addition to the biosphere, which contains the life, and the lithosphere, which contains the rocks, and the hydrosphere, which contains the water on the planet, we have the atmosphere. When I say atmosphere, you automatically think about the oxygen that we breathe, but our atmosphere is multi-layered as well. And so now we are going to work our way out from the planet talking about the atmosphere. Our first level of atmosphere is called the troposphere. These are not going to be drawn to scale, guys. The troposphere. Troposphere. The troposphere. The troposphere goes up about to 14.5 kilometers. The troposphere, whoa, that's not what I wanted to do. The troposphere contains all of our weather. So I'm going to write it this way because I can't turn my pen. So this is where our weather occurs. And this is our air we breathe. All right. One step up from the troposphere. Let me change my color pen. One step up from the troposphere is a term that may be familiar to you, and that is the stratosphere. We talk about things going up really high. They hit the stratosphere. I'm not doing very well on my circles today. Okay. I promise this will look nicer on the board than how I'm drawing it here. So the stratosphere reaches a height of 55 kilometers. Stratos. Okay. Most planes, believe it or not, are right about here. Here's my little airplane. Most planes fly at about 16 kilometers. This is planes. Planes fly at about 16 kilometers. Outside of the stratosphere is the mesosphere. We'll make that be pink. Ooh, I am drawing this bad tonight. I'm sorry, guys. All right, the mesosphere. Let me make my pen a little bit smaller. The mesosphere, now we are at 100 kilometers above the Earth's surface. Ooh, and I'm running into the earth science. Learning all sorts of things about this program tonight. I need some room. All right. Put it back on my pen. Mesosphere. All right. The mesosphere is a unique level of the atmosphere. In the mesosphere, as I find my pink pen again, something happens. Here, the air is so thin, I'm going to write it down here. Here, the air is so thin that it doesn't hold the heat from the sun. And it's so high at 100 kilometers that it doesn't get any heat from the planet anymore. So it's so high, it doesn't get warmed by the Earth. So that's in the mesosphere. Very, very cold. Between the mesosphere and our next layer, there is a very high, I want to make that be green, and you'll see why in a minute. There is a very high, we'll use rainbow, thin layer that kind of bridges the next two layers. This is called the ionosphere. I'm just writing it out sideways because I can't turn my pen. The ionosphere. The ionosphere is millions of charged particles. That get caught in our magnetic field, and the ions come from the sun. And this is where our aurora borealis gets formed when we have waves of solar radiation coming from the sun. You can see them at the really high latitudes. The aurora borealis is in the north, and the aurora australis is in the southern hemisphere. So that happens between 100 kilometers and 700 kilometers. So that brings us to our next layer. We're going to draw it out here. Do, 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 do. As I said, it is at 700 kilometers above the Earth's surface. And this is the thermosphere. This, in the thermosphere, is where satellites are. LLI, crying out loud. So, satellites in the space station are still, we think of them as being in outer space, but they are 700 kilometers up in the thermosphere. We're still not out of the atmosphere just yet, even though most of us think that we should be. The outer layer of the atmosphere reaches 10,000 kilometers above the Earth's surface. And the outermost layer is the exosphere. So, the exosphere, thermosphere, mesosphere, stratosphere, and troposphere all make up the atmosphere. So this is all the air we breathe, all around the Earth. So these make up the atmosphere. I'm going to get rid of some things. Hold on. We'll just throw these off to the side. Things never chunk up when you want them to. All right. So our atmosphere said is the air we breathe. And if I asked you, what is in the air we breathe? You probably would all say oxygen. But oxygen is not the most abundant element. It's actually nitrogen. Our atmosphere is only 21% oxygen. It's 0.9% argon and 0.04% trace gases. And that is our planet. Let me get rid of these. That is our planet. Tomorrow, I will be talking about the rock cycle and beginning to talk about how crystals are made and how our continents are formed. After that, I'll be talking about our oceans and our weather. Thanks, guys.